Hello and welcome to this lecture. We're going to be looking at Unit 9, Charts and Simulations. And let's start with charts here. If you go to Blackboard, you can download the file 410 Working with Charts that has this data, Gizmo Company. I think we may have seen something like this even before. Here's that file once we download it. And in your reading, we talk about three types of charts. Bar charts, which are good for comparing grouped data, and it's really easy to use charts in Excel. So as it says in the reading, if you do the range A4 to G9, which is right here, that gets you the labels Monday through Saturday and the shirt sizes and the data, you can then create a clustered column chart. So let's go back to Excel and do that. Select the data, and under the Insert tab, we can, under the Insert tab, we can, under recommended charts, the cluster column chart is the second option. These recommended charts are unique, depend on the selected data. It has, based on experience or hard-coded rules or something, it's able to say based on the data selected, these are probably the charts you want. If you go under all charts, you can do them by group. So all the column charts, all the line charts, all the pie charts, you can kind of see for whatever is selected. You get every chart type that Excel has in this group. So somehow get to a clustered column chart and select that. Right. And when you have a selected chart, you can change the chart types till you find one that you kind of like. You can even go even further under the chart elements, turn on and off the vertical axis, the axis titles, the chart title, where do you want the title, do you want it to be overlaid or above? So these chart elements, one at a time, going through them and customizing your chart to be exactly the way you want it to be is kind of a neat thing. The design chart options, they make large changes to the entire chart all at once based on some chart styles that people have liked in the past. We can also do bar chart or pie charts. Pie charts are good for showing parts of a whole if you're doing percentages, for example. And with a pie chart, typically the way you're going to do it is you're going to have labels and then data for those labels selected. So we're going to select Monday through Saturday, and we're going to select the data for Monday through Saturday, and we're also going to select what this data is. It's medium shirt sizes. So select the range A to G, and then do a multi-select by using the control key, and hold control and select on row 7 A to G, so both are selected at the same time, and then insert a pie chart. So A to G, multi-select by holding control, A to G. Now I let go of both the control and the mouse. I can come up here and say insert. Again, recommended charts is different now. I can go under all charts. In the pie area, I can see a list of different pie options. Let's do a 3D pie chart. We can do versions of the 3D pie chart. And you can select a slice of the chart. Selecting once selects the entire chart. Selecting again selects a slice within the chart. And you can pull that slice out and do some things. As you resize, the charts automatically do what they're going to do. Again, it's very, very, very nice what Excel does for you when it comes to creating charts. And one more chart here. It says line charts. Line charts are good for showing trends over time. So in this chart, we're going to, again, do a multi-select. We're going to compare medium and large sales for the week. So select the labels, Monday through Saturday, and then including the chart names, medium data and large data, and then we'll do some type of a line chart. So let's go back to Excel, get the titles, multi-select by holding control, medium and large, and let's see what we have here. It gives us different under the recommended. I can go under all charts. I can see all the different line options. Line options are good for showing trends over time. This one is probably what I want, this generic first one, the line chart, but there's stacked line and some other options there depending on what it is we're wanting to do. Here we have line with markers. So let's do line with markers actually. So it's what's selected. I say OK, and we have a line with markers chart. Do different versions of that line with markers chart. Right. And more layout options under the quick layout. So we can have the data visible, graph the distances for each of the points, right? So there's a lot. It's worth spending a few minutes looking at all the different elements, all the different built-in, easy way to get things done quickly aspects to using the chart. So if I want the data labels to appear next to the points, I can make them appear at different places and so on. Okay, so that's all pretty cool stuff. Now, the reason we're introducing this in this chapter is because we're going to talk about simulations, and we're going to visualize the results of our simulations. So a simulation, it's a computer program that models some real-world activity. Rolling a dice. If I roll a dice, I get a value from 1 to 6. Well, if I roll it 1,000 times, I get a lot of different values. So here's a little program, a 1-dice histogram, that has a loop variable I that goes 1 to 1,000. And you can see what we're doing here is every time through the loop, we're doing two things. We're creating a variable. The value for roll is a random variable from 1 to 6. And then we're updating a value on the spreadsheet by taking the current value at the spreadsheet and adding 1 to it. Right? So this is something equals itself plus 1. So we're adding 1 to something. Well, what's the something we're adding 1 to? It's on the spreadsheet, down roll plus 3 over 3. So if roll's a 1, we go down 4 over 3. Well, down 4 over 3 takes us right here, and that's where we're counting the number of times we've rolled a 1. And if roll's a 6, we go 6 plus 3, 9, comma over 3. So down 9 to row 9 over to 3, column C, and that's how many times we've rolled a 6. So basically these values from C4 to C9, but depending on roll, that random value from 1 to 6, it's going to be 4, 5, 6, 7, 8, 9. It's going to be one of those rows down and always over to column C, the third row over. And we just update. So if I roll one more time and I roll a 4, this 179 becomes 179 plus 1, 180. And then I update the cell, the spreadsheet at that position to be 180. So by just counting these values this way, and you can type that code in, these values will change. The rest of it you just kind of type in. And once we have that data, you can create that histogram. And we can see that it looks like, it's interesting, after 20,000 rolls, it looks like the rolling of one dice, it's not very consistent. This is actually a bit of a trick in graphs and presentation. The old statement, there's lies, damn lies, and statistics. This is an example of why that statement would ever have been made. We're rolling one dice 2,000 times. The likelihood of getting a 1 or a 2 or a 3 or 4 or 5 or 6 should be essentially equal. But if you looked at this chart and you asked somebody walking by on the street, looking at this chart, according to this dice, is this a fair dice or is it loaded so that 4s come up more often than anything else? They might think, oh yeah, it's a loaded dice. The reason it looks that way is over here on the left axis. We've done 20,000 rolls, and we're looking at just this little slice between 3,200 rolls and 3,400 rolls. And at that level, there is some variation, but if you change that vertical axis to go all the way down to 0, you can see that, yes, there's slight differences, but that looks a lot flatter than the chart version above it. And both of these charts came from the same data, right? Chart 1 and chart 2 are the same. Chart version 1, chart version 2 is mapping the same data using bar charts, but the only difference is where we have our 0 axis. So I say that to tell you, one, to be skeptical of data, not dismissive of it, but if somebody shows you a chart that says you need to sell your house in the next 5 minutes, you should be skeptical, right? Where did that data come from? And another level of skepticism, how are they presenting that data? Are they presenting the data fairly? So here's a 2-dice histogram. So we set up the spreadsheet to have the results of rolling 2 dice. And if you get the lowest you can roll on 2 dice is 2, and the highest you can roll is 2 6s, which is 12. So we have our sheet spread up to roll, create a histogram for rolling 2 dice. And here's the code on page 8. Looks like just what we had before, except the roll is equal to random 1 to 6 plus random 1 to 6. And it's important that you do it that way and not say random 2 to 12, because you're more likely to roll a 7 than you are to roll snake eyes. And this captures that. This is a more accurate representation of what's happening in the real world. I roll 1 dice, 1 to 6. I roll another dice, 1 to 6. Simulation data is not perfect. It's only as good as the model that you're using to represent in code and gather the data. People have built amazingly good simulations on a number of things, but it's a fair criticism that the models aren't perfect, but they are very good and they're very useful. And if you fix the model, make it a little more accurate by getting more data or more information or more eyes on the model, your simulation results are even better. So if we roll that 20 times, right, that says 2,000 rolls, but I think it was actually only about, I can see it's only 20 rolls so far. The chart looks jumpy. And after 200 rolls, it's starting to take a shape, and after 2,000 rolls, it actually looks like what the histogram should look like, which is that 7's by far the most common, and then 6's and 8's are next, and then 5's and 9's are after that, and it slopes down on both sides. One of your homework problems is to write a 3-dice histogram. But where you're really going to spend, I think you can do that pretty easy, where you're really going to spend the most time in this homework assignment is this last part, the Las Vegas dice game simulation. Now, you worked on the Las Vegas dice game last homework with, some of you had more success than others on that. I'm going to give you the code, so if you didn't have it last class, you're okay. We'll look at this code here in a second. But we were only playing basically one game of Las Vegas dice. In this chapter, what I want us to do is I want you to say what happens when lots and lots and lots of games of Vegas dice are played. What conclusions can we draw about the results? So we're going to set this up by creating a spreadsheet that's going to have data on the spreadsheet that's going to be our running totals of how many wins did we have and how many losses did we have. And you can see here that E2 and E3, this is where we're going to put how many times the player won and how many times the player lost. Now we're going to gather more information. We're going to say, how many times the player won on the first roll of the game and how many times the player lost on the first roll of the game. That's E2 and 3. And then if you don't immediately roll a 7 or an 11 to win, or a 1, 2, or 12 to lose. The game goes into a multi-roll format where you keep rolling, and a 7 is bad in a multi-roll format, and whatever you rolled on your first roll is now your target. So that game eventually ends with a win or a loss, and then we add up all the wins, whether it was a first roll win or a multi-roll win, and all the losses, whether it was a first roll loss or a multi-roll loss. And you can set this up to make it look however you want to, but in this example, I've got E2, E3, E5, E6, and E8, E9 as the places in the spreadsheet where the data is going to be. So it's down 2 over 5. Column E is the 5th row. Down 3 over 5. Down 5 over 5. Down 6 over 5. Down 8 over 5. Down 9 over 5. And the code for doing this is right here, but you'll see, I'm actually referencing the ranges in string literals here. Range E3, E4, E6, E7, right? So we're being explicit with where we're putting these values. So it's here's what it looks like after we've done it. You type in that code, you set up your spreadsheet. We also add in here in cell B3, we add the place for the user to type in a value. And the value they're going to type in is how many runs you're going to make. So if I say 100 and click the dice, it's going to run 100 games. If I say 5 in cell B3 and click play dice, it's going to run 5 games. 1,000 games. And the way that code works, let's actually pull it up in Excel so we can see what's going on here. Actually, here, I'm just going to do this way. Just do this from scratch so you can see this. It won't take long, and we'll do this. Okay. Let me go back to my document here. So let's do it exactly like we've got. As I noticed, this figure is actually, I've got it on E2, but the code actually has it on E3. So let's look at the figure on page 11. That's the one we're going to mimic, the figure on page 11. I'll make this a little bigger here. And these are where my values are going to be. Column E, 3 and 4, right? 3 and 4. And this is player wins first roll. Player loses on first roll. We'll resize that. So this is still my t-shirt sales document. It doesn't have to be, but it could be same or different. Player wins multi-roll. And then our totals here. Total wins and total losses. And this is just using Excel, right? It's just this value plus this value. I could do it using the sum function. I could do it by saying this cell plus this cell. Either way, right? The sum, I'm adding those two, adding the 2 wins, and I'm adding the 2 losses, whichever way makes more sense to you. But we're over here on B, how many games? And then B3 is where we're going to type in that value. And I'm just going to highlight this just so it's visible to the eye and it makes it easy for the user to see. We'll say 100 games. And I'll center this text just for visual, right? This isn't changing functionality at all. That's just making things easier to see and work with. And we're going to insert a button here, a command button, and write that code that appears back here on page, what page are we on here? Back on page 11. We're going to do the add games to simulation. That's going to be the routine that we're going to trigger with the button. Now I could write the code first and then write the button to trigger the code, or I could add the code here. Developer, here's my developer window. Oops. Sorry, didn't have that resized before I pulled it up. So I could write the code first and then add the VBA button to trigger the code. Or I could go back to Excel, or I could insert the button here and have it create the subroutine stub for me. I don't know which one's better. Neither one's particularly better. But if I have it create the stub for me, the thing I have to remember to do is, whatever the name of it, I have to remember to click the new button, because the new button creates a new macro. The OK button is when you have something to select in the list and say OK when it's selected. But if I just click OK, it won't create a new stub for me. I have to do the new button to create the stub, and it creates that stub. So let's write that code. And that code is available right here. Let me type that in real quick while you're on pause and come right back. Boom. Okay, and we're back. So I typed this in straight from the PDF. And I can't see all the code here, so let me change the editor here. I'm going to make this a little bit smaller, so hopefully my code shows up in the window and be easier to comment on it here as we're talking. And I don't have an option explicit in the PDF. But I definitely want to put this in here because I wrote a lot of code. If I have any variables wrong, I want the VBA editor to flag me and let me know that I've done something there. So add games to simulation, we declare variable I, and we're declaring it as long, not integer. Why, you might ask? Because if you remember, when we talked about integers, we said they're limited to 32,000, 32,787 or something like that. Because they're 16 bits, and at some point, if you have all 16 bits set to 1, it's an upper bound value of something, and it turns out to be 32,000. If I want to run 40,000 simulations at once, it'll get an error to try to say for I equals 1 to 40,000 when I is an integer, because it has an upper bound. By making it long, I get an integer value that's way more than 40,000 and is going to meet our needs. It runs slightly slower to use a long when an integer would do, but if you might possibly maybe go over 32,000 with your loop variable, then you absolutely would want to go ahead and use a long type there. It's not, computers are so fast now that it's not a problem at all. And what this add games to simulation, which is what I'm clicking when I hit the button, what it's going to do is it's going to call this routine, play one game and update results, however many times I have a value in B3. So if the value in B3 is 100, it's going to call play one game and update results 100 times. If B13 has 5,000, it's going to do play one games and update results 5,000 times. So play one game and update results is the other routine here, and this is the code for playing the Vegas dice game. Some of this looks like kind of what we had last class, but in your reading from last time, but we've finished the code, and hopefully this is going to make sense. And we've also taken out the message boxes because I want to be able to run 5,000 games without a lot of message boxes popping up. So here we go. First roll, new roll. First roll is random 1 to 6 plus random 1 to 6, right? And that just says that's another 1 to 6. You've got that in your printout there. Then we can see that we test. What's the scenario for winning on the first roll? If it's a 7 or 11, then you won on the first roll. And what we do is we go to E3 and we say whatever E3 is, add 1. That's the new value for E3. Else if the first roll was a 2, 3, or 12, then whatever is on the cell, the spreadsheet on cell E4, add 1 to it, and then save the results in E4. So update E4. If it's not a first roll win or a first roll loss, then you get into a multi-roll game. And we handle that in this else clause that is contained mainly by a loop. So we have this large do loop here, right? Else multi-roll game. So here's the multi-roll game code, and this is what you didn't have in your handout for last class. So looking at this now should help you see how to finish the Vegas dice game. So we have a new roll. So we're doing this, all this code is inside the do loop. So we're repeating one assignment statement and a multi-line if statement. We're repeating that many, many, many times until the new roll is the first roll or the new roll is a 7. Right? That's the only thing that's going to get us out of this is we're doing this. So we have to make sure that inside this loop we're updating new roll because that's what gets us out of the loop. New roll is random 1 to 6 plus random 1 to 6. Great. If new roll equals 7, then that's a win. And a multi-roll win, which we're counting those in cell E6. So we say E6 plus 1, whatever it was, add 1 to it, becomes a new value for E6. What if it was a multi-roll loss? What if the new roll was, I said those backwards. Oh my gosh. No, I got it right. You want to roll a 7. Yep, see, I'm actually got that code is actually backwards. Darn it, I'm going to have to fix it in the handout here, so it'll be different if you download a new copy of the PDF. I'll have it fixed, but I actually had that backwards. If new roll's a 7, that's the way you lose in multi-roll. New roll equals first roll is a win, so those two are actually completely backwards. Logic error, but the code's exactly the same. You understand what's going on, and in your PDF it should be correct. The code should be correct. So we have all that stuff. We run the code, go back to Excel, and we run the game many times, and we start seeing things happen. So let me zero these back out. I'm not going to zero the sums, right, because they those are formulas. I don't want to zero those out. So if I just run 10 games to keep it simple, right, 3 wins on the first roll, 3 losses on the first roll, 4 wins on multi-roll, no losses on the multi-roll. 3 plus 4 would be 7 wins, 3 plus 0 would be 3 losses, right? So that's working for us. Let me change the code here to make it correct. Okay, so getting back here. So doing that again, 10 into after 20 rolls, it's even, right? After 30 rolls, 40 rolls, a few more wins than losses. Now that would be bad for Las Vegas if after 40 games there were people winning slightly more than they were losing. That's not the way it works, right? Because if I keep rolling these things, eventually a number of losses start outweighing the number of wins. Now it might pass it again. I don't see it crossing that threshold again. I'm just comparing. I'm just watching wins and losses here, seeing if they if the number of wins ever outnumbers the number of losses. And it doesn't. It gets close, but it doesn't. That's the way Vegas works, right? That's why there are large buildings in Vegas, because sometimes people win, sometimes people lose, but over the long haul, more losers than winners. That's why there's very large buildings in Vegas. So what if we did 10,000? Boom, so there's 10,000 games, and we can see these numbers going. So we can chart these. We can chart each one of these individually. Here's the most important one, the wins and losses. I'm going to insert a donut chart here. So this is total wins and total losses, right? And call it whatever you want to and format it. And it looks pretty even, right? That's after 10,000 games. It looks pretty even. Let's run another 10 more thousand games, and it still looks pretty even. And that's good for Vegas too, because you want to have, and so you can see that the losses are slightly more than the wins, but to the average player, it looks like a fair 50-50 toss. But it's not quite there. That chart actually is kind of confusing looking, because it looks like, quick eye, it almost looks like losses is higher than wins, but I know it's not, because I can see right here that losses is slightly more. So that's just the way it's drawing it for some reason. Let's see. So talking about formatting, one of the things I can do on my formats here is I can have it put the percentages in, so that makes it a little easier to see what's going on. Oh, it was. I'm sorry. Losses is higher. Losses is on this side. The wins are on the left. So yes. If I want to do one of these charts here, which is the one I just had, right? So there's one, and you can do other versions of this. If any of those you like any of those better, that's as good as any. So there's about a coin toss, but slightly favoring the house over the player. And I can also do these charts for the same thing here. I can do it for this, insert the charts, and it might be interesting what we see here. Here's the chart on first roll games. So here's single roll game results, or however you want to describe it, but games that involve only one roll. And looking at our numbers there, right? Players winning a good percentage of games that are only a single roll. And then finally, games that are multi-roll games. So here's a multi-roll game result. Here's single roll game results. And if I had the space on my screen, or I can't show it to you on this recording, but total wins and losses. Okay. So that's data that can be used by the players if they had access to it. It's data certainly that can be used by the casino and the hotel so they can make decisions. We see that a single roll game, players actually win the majority of single roll games. And multi-roll games, the house wins the majority of multi-role games. And overall, which is what really, really matters, the house wins. Your ability to visualize this simulation and show these results from data that you created using your own simulation, data that you simulated using VBA code, and then charted using Excel is a nice little activity. And I think you'll see that at the end of the assignment, there is, if you want to do multiple files, it's fine. You can do like I did here and rename that file or something. But at the end of the assignment, there is a bonus question, which is to say, I want you to, oops, sorry, that was off the screen. The bonus question at the end is review the simulation results and give me a theory. Tell me what you think might explain why Vegas dice is such a tempting game for gamblers in Las Vegas. Right? Is there any reason that you can think, based on your analysis of your simulation and the results of your simulation, why Vegas dice is tempting? I mean, they have a chance of winning, but that chance, 49, 51%, that's probably the same 49, 51% we have at the roulette table. It's probably the same 49, 51% chance you have playing blackjack. And if we wanted to know those percentages, we could write VBA code and simulate it. It wouldn't be that hard to write a VBA simulation of a roulette game. It wouldn't be that hard to write a VBA simulation of playing 21 blackjack. The blackjack would be a little bit harder, but we could write those. We could gather data, we could see the results, and I strongly suspect you would see a 49%, 51% split for all three of those games. But there's something that's especially compelling about blackjack. The number of people who play blackjack is even higher, who do craps. The attention for craps and the high gamblers like craps. There's something about it that's tempting. And come up with a theory. Can you think of a reason why that might be? I'd like to hear your analysis. Your programming, your code will tell me that you did the technical side of things. Now switch off the technical side and give me the human analytical side. What can you tell me about human nature? What can you tell me about people and behavior so that we can drive decisions? What kind of recommendation or insight can this data give? So look forward to seeing your code. Submit it by the due date. And if you want to include in your spreadsheet somewhere, just make a note at the top or to the side that tells me, my theory. And tell me what you think it is, or my insight, my analysis, something like that. Okay, very good. Have a good day.